In the last video, we have finished implementing part of the input reader class. In this video, we will try to finish the read input module. Here we have created a jagged array of tile-based values, a concrete implementation of iValue interface. For that, we needed to call another method called read input tilemap that I will create shortly. We also need a helper method called create jagged array. So let's see what is the definition of it. Let's go to the definition, and let's go to this link. So this code was copied from Stack Overflow, the equation about initialization of jagged arrays, and here it is by DTB user, and it's a great implementation, and that's from where I got this. And as you can see, we are using it by passing a type with the size of number of arrays we are going to use. So it was one array, 1D array, we would pass 1 square brackets, and we are passing 2, so it's 2D jagged array. And we are passing the values for length, so the rows first, brackets, and columns number, so second one. And we are using those rows and columns in our for loop iteration, and we are filling in the grid of values as new tile-based value placeholders that we will fill in with our tile-based values from our tilemap grid. The create jagged array method will be used throughout this tutorial for easier creation of jagged arrays, so that's why we have created a helper method for it. Okay, so let's go back to the tile-based value concrete implementation of iValue, and let's finish this class. The constructor has been created and it did its job. Now we need to implement the remaining methods. So our value, the parameter from our interface, will return the this.tilebase. Now, additionally to those methods, we also need to override the get hash code, and it will be returning the this.tilebase.get hash code. This is a trick used inside the when using the equality comparers and the interfaces connected to it. Okay, so now we can start with get hash code, the method from the interfaces we have implemented. Return object.get hash code. So here we are returning the result of this method. Okay, now let's change the equals return value, and we will compare other.value to our this.value. So we will compare the tile-based values, and equals, again, return, and we will call x equals y. And I think we're done with this class, the tile-based value interface. The tile-based value concrete implementation of our iValue interface will be storing our tile-based values, so the tiles from our tilemap. For your own implementation, for any other input value, you would have to create your own concrete implementation of iValue interface. Great, so let's see what we have so far. Let's go to Unity and our to our scripts, and we have input reader interface, iValue interface, concrete implementation of tile-based value, and input reader that is not finished. So let's go to it and finish this class. Okay, so let's finish read input tilemap method, and here we will introduce a helper class, input image parameters equals new input image parameters, and we'll pass it our input tilemap. And we will return create tile base grid, and we'll pass to it the image parameters. Okay, great. So we need to create this class and this method. So let's create the placeholder for this method, and let's create our input image parameters class. So let's go to the Unity and let's create new class with the same name. Let's open it, delete the mono behavior, save it. Okay, so let's place it in our namespace. Okay, good. So this class will process the tilemap and extract from it tiles. A tilemap is a structure that stores tiles as a 1D array. This means that we do not have a straight up grid-like structure, but we need to create one. We can read the bounds of our tilemap, but they do not represent the painted tiles. Let's see in the editor. Okay, so you can see the outline, and the actual outline of our tilemap is bigger than what the tile represents. That is why we need a method that will extract the tiles that are painted from the whole tilemap. Okay, we will need some fields. We'll use vector2 integer with a question mark. That means that it can be a null value, and we will call it bottom right tile chords equals null, and we have the same for top left tile chords. Those two values will represent the corners of our tilemap that we will search for, the bottom right corner and the top left corner. We will need the boundaries of our tilemap. So let's create bounds int input tilemap bounds. Okay, so this will store the bounds of our tilemap. We need the storage for our tile base array extracted from our tilemap, tile base, and we need to import the using Unity engine tilemaps again. This will be an array, and let's call it input tilemap tiles array. Okay, we also need a queue of tiles. We will be adding to this queue the tiles that are painted or are not null from our extracted from our tile base array that contains all null and non-null tiles. So let's create a queue, and it will be a queue of tile container, another helper class, and we will call it tag of tiles equals new queue of tile container. And the last thing we need is width and height value. So let's create private ints equals 0 and height equals 0. Okay, so we have yet another class to implement, so let's create it. Let's create our tile container helper class. Let's go back to Unity and create new C# tile container. And since it's a short class, we will open it and create it. Let's create it in our namespace. Let's delete the methods. Okay, so tile container is a simple class that will help us store tile-based objects, so tiles, and assign it to X and Y coordinates, or rows and columns depending on how you understand the grid structure. This way our code will be much cleaner. So we will store the tile base and X and Y coordinates of it. So let's create our fields. The public tile base tile. A not tile base value. So we need again import tile maps. And let's create it into a property. Get set. Okay, let's use the shortcut. Prop integer X and prop Y. Okay, and let's create a constructor, and let's make it take tile base int X int Y, and we assign those. And that's it. That's the whole helper class. So we can go back to our input image parameters. We'll create some properties for accessing the stack. So let's Alt enter it and encapsulate use field. Great. And let's create the same thing for width and height. Okay, and I've added one too many. Good. So now we need to delete the set from those, as they will never be set. We'll only get those. And I think okay, it can stay like this. Great. So we have the accessors. And now let's create a constructor. And I believe we had the constructor for this input image parameter. So we can generate it constructor. So let's get back to input image parameters. And we have our constructor ready. So let's assign our values. Let's move the constructor below the properties. Okay. So we have our input tilemap, and we call this input tilemap bounds. Call this input tilemap cell bounds. Okay, next, this input tilemap array calls this input tilemap get tile block, get tiles block, and we want this dot input tilemap bounds. So we will get all the tiles inside the cell bounds, and we need two methods: extract non-empty tiles and verify input tiles. Okay, let's create placeholders for those. Okay, so let's go through extract non-empty tiles method. So in this method, we'll loop through the input tilemap bounds and extract the tiles that are non-empty, so the tiles that are painted onto tilemap and thus contain a tile. So let's go for it. First, for row in put tilemap bounds size I, another for loop, columns, and we'll copy the same thing but now for X. And here we need to calculate an index of our 1D array based on our row and column values. So let's create index equals column plus row times input tilemap bounds dot size dot x. Now calculating the index, to better understand what is happening, we are creating a 1D data structure as a 2D grid. And in this question on Software Engineering Stack Exchange, you can see a description on how to calculate an index based on coordinates and width of our array. And the same goes for going back from the index to coordinates. So I encourage you to visit the link, it will be in the description. Okay, so let's finish this method and we'll talk about what it is exactly doing. So we create a new tile, base tile, equals input tile by tilemap tiles array index. So we are getting the tile from the index, and if bottom right tile coordinate equal to null and tile is different than null, and we can say that our first tile is our bottom right tile, equals new bottom right tile coordinate equal new vector to int column row. And to understand what's going on here, we should visit another link. So this is a .NET tutorials on two-dimensional arrays, and we should look at the jagged array example. Here it is. Two-dimensional arrays which will also store data in form of rows and columns. So I encourage you to go through this tutorial if you're not sure about jagged arrays. But basically, the jagged array let's go back to our method. So basically our jagged array stores values as row first and column second. But if you go about it as a Cartesian plane, we would imagine that columns are x's and rows are y's. Those rows are on the y-axis and columns are on x-axis. That's why we create vector to int and pass column as x and row as y. So we have found our bottom right tile chords, and next, if tile different than null, we will enqueue the tile and set it as a top left corner. Stack of tiles, enqueue, and here we are using our tile container. It will store our tile and x and y coordinates, and we will set top left coordinates equals new vector3 int, and I should have put here column and row. So basically in this method we leap through the array of tiles we had extracted from our tilemap. We know the boundaries of the tilemap and we calculate which index fits them. The calculation is simple if you try it on an example. Basically, if you start looping from the bottom left corner, each cell has index the same as a column index. If we go up a row, we must additionally add a row index multiplied by column size. You have seen it in the treating a 1D data structure as 2D post that I have shown you previously. If not, please visit the link. The link will be in the description. So basically we want to extract corners, the bottom right corner and top left corner, to find the width and height of our area where tiles are painted. And we want to enqueue each non-null tile into our queue. And this will allow us to recreate the grid from our 1D array stored in a tilemap into a 2D array that we will extract from it and pass it to further classes. But we also need to verify if input is valid. So let's now implement verify input tiles method. First of all, we will check if the corner tiles are not null. In that case, we'll throw an exception. We'll throw a new system exception, wave function collapse, input tilemap is empty. If it is not the case, we'll calculate the min and max y and x to find the boundaries. We need to use value as it is a vector2 that can be null value. Okay, so now we have our min and max x and y values. We can now calculate width and height of our area with tiles on it. So here we need to add 1 to width and height because we are working with indices and indices start from 0, but counting the width and height start from 1. So that's why we add 1 to account for that difference. So now we check for if the stack of tiles that we have created has the same code as the field of our rectangular tile map, and whether any tile is outside of the bounds of our rectangle. As we have previously discussed, we are accepting only a tile map that has no holes in it and no outliers. So let's go and implement it in code. And here we throw another error. We'll copy the error. Throw new system exception. Wave function collapse, tile map has empty fields, so has holes in it. And another if. And here we will check if stack of tiles, any of the tiles, and this we will be using is system.link to query our stack or our queue and tile, such as using lambda expression tile.x is greater than max x, or tile.x is lesser than x, or tile.y is greater than max y, or tile.y is lesser than min y. And here we are checking if any of the tiles is outlier. So if any of the tiles lies outside of the bounds of our rectangular image that we accept, and we will call another error here. We'll copy the error. Throw new system exception wave function collapse. Tilemap image should be a filled rectangle. Okay, so for summary, here we perform checks. Did we find corners? And is the image the tilemap of a rectangle with non-empty tiles and no outliers? The latter check is made through checking the count to find if we have empty tiles in the rectangle, and through coordinates check if we have any outliers outside our rectangular area. Finally, we can go back to our input reader class and create the remaining methods. Okay, I believe this is the last method for this part. And here, in this method, we are going to create a new grid that will store our tile base values read from our tilemap input. So let's create tile base, jagged array, grid of input tiles. And we make it equal null. And we then have, or we could actually from the beginning create a my collection, create jagged array, tile base with double square brackets, and the size will be image parameters dot height for rows and image parameters dot width for columns. So that's why we have created those two parameters inside our image parameters class, and now we will loop for it through it. And we will call grid, the one we have created, row and column must be equal to image parameters, stack of tiles, and we will dequeue and get the tile. Because as you remember, we have started from the bottom left corner, and we are filling this grid of input tiles also from the lower left corner. Okay, so now let's return the grid of output tiles. So now we can actually test if everything went smoothly and create a monobehavior script and instantiate our input reader and see what are the results. So let's go to the editor. Let's go to the core script folder and create new C# script called test. Let's open it. Let's create a public tilemap. Let's import using tilemaps and call it input. And here we also need to be using wave function collapse namespace. And now all we need to do is instantiate our input reader. Reader equals new input reader and take in the input, our tilemap. And we need to create var grid equals reader dot read input to grid. And we can now loop through rows using grid dot length and loop through columns using grid dot zero value length. And now we can debug that log and row plus space column plus column and plus tile name, and we will be printing grid.value. Remember, we are accessing iValue surface instance, the grid, and we are calling row, column, and now value. And now we are accessing tile base class, so we can call name. And that's it for the test class. Let's go back to Unity again. And let's create our empty game object, test object arrayed. Let's add our script here. Let's table maximize on play. Place the input tile and press play. And we can see the names of our tiles. So at position 0, 0, so bottom left corner, we can see tile 33. Let's go to sprites and let's see 33. The game is the road, and number 4 is our straight road. 19 is the other end, and you can check other tiles as well. So you can be proud of yourself. We have created the first module of reading the inputs to our algorithm. In the next part, we will take a look at implementing value manager, so intermediate class that maps our values into integer indices. So see you there.